talking about reliable internet stream transport. And the beauty of RIST is that it supports not only RTP streams, but or MPEG-2 streams, but all types of RTP streams. So it's a really flexible format, and I'm sure our panelists will do a great job of introducing you to the format and telling you about why it was created and all those other good things. So without further ado, I'm going to introduce Ciro Noronha from Cobalt Digital, who will introduce the rest of the panelists. Here you go, Ciro.
Thank you very much. My name is Ciro Noronha, Director of Technology of Compression Systems at Cobalt Digital, and also heavily involved in RIST, but since I'm the moderator, I'm going to shut up. So first thing we're going to do is have the panelists introduce themselves.
Yeah, so Mikael Wånggren at Panelists, senior software engineer. I've been with our media transport product for 7 or 8 years since it started. So.
Uri Avni, CTO and co-founder of Zixi. Been in this industry for 12 years.
I'm Kieran Kunhya. I'm the founder of Open Broadcast Systems. I've been in this industry, I don't know, 7 years maybe, something like that. Yeah, my company makes video transport products, but I'm not a RIST politician. I'm just the engineer, so I'll say what I think.
Okay, say what you really think.
Yeah, I did yesterday, as you saw.
Yeah.
All right, I'm Sergio Ammirata, CTO of DVEO. I've been in the industry for about 10 years.
Okay, thank you guys. So, RIST. First, an easy question. What is RIST and why do we need it? Anybody?
It's a B2B-based transport protocol, so for getting content from essentially B2B services between businesses, between broadcasters, as opposed to other protocols like HLS and Dash, which are for consumer use. So low latency, error recovery over unmanaged networks.
Okay, anybody else?
It's a way of transporting data using the UDP protocol reliably across lossy networks.
Okay, a whole bunch of companies, yourselves, most of you included, have proprietary products that do that. So why are you endorsing RIST?
One of the reasons is interoperability with other platforms, other vendors, like the vendors that sit here. The world of reliable transmission of broadcast quality signals over IP was very fragmented before of RIST, and now it looks like it's a step towards consolidation of a single transport technology that will allow vendors to interoperate.
Right, from our point of view, it's going to actually increase the use of the technology by the fact that customers won't be afraid to jump into it because it's one vendor or another. They know that if they jump with vendor A, they can still send streams to vendor B.
Okay, anybody else?
Yeah, for us, as I kind of mentioned at the beginning, we joined RIST and implemented RIST, not just for the interoperability, but to reach a greater understanding across the customer base that streaming solutions, HLS Dash, as I mentioned, are not the same as professional transport solutions. They have different goals and different use cases. And being able to join RIST meant that we, as an industry, could come together and help promote this.
Okay. By the way, if you guys have any questions, stop me and I'll give you the mic. All right. RIST has been deployed in the field already. So any of you want to talk about actual experiences deploying RIST?
Yeah, I have a lot of RIST deployed in the field, and quite a lot of viewers take these feeds. It's been relatively straightforward. As I mentioned yesterday, if any of you came to the RIST forum, which you should join, the marketing association, one of the most simple things about RIST is IP engineers can debug the issues very easily. RIST is based off well-known standards like RTP, RTCP. They're already Wireshark dissectors, TCP dump, that meant as soon as we fired up streams, customers can make sure they're already there. If they do have issues with the network, they can see that it was the network's fault. That's been really, really useful, and it's really been plug and play. The other thing RIST that can do that other solutions such as SRT can't do is have native built-in bonding. That's bonding or load balancing across multiple internet connections. That's been, in fact, for this particular project, that's why it's been particularly useful. But RIST is really get up, plug, and go.
Okay, thank you. Anybody else wants to talk about actual deployment experience?
I'm not sure if it's an actual deployment, but it is an offering that everyone can use RIST today in Amazon. AWS announced this trade show that they support RIST in and out of their AWS Media Connect service.
Excellent.
We have one particular deployment between clouds, between an Amazon and Azure cloud, point-to-point, 12 megabits. Work really well.
Okay.
Yeah, I would say we had people trying it out, but since we already have a different implementation, then since we didn't have encryption yet, it was kind of a, yeah.
Okay, so you brought up encryption, right? RIST has something called Simple Profile that's missing some features. And then we moved on to Main Profile, where some of those features appear. So talk to me about what's missing in Simple Profile and what are we doing about that?
Yeah, I can take it. Yeah. So first of all, encryption, of course, and also a pull mode, so you can have, or if your receiver is on behind the firewall, yeah, and yeah, what else?
Another thing that's missing in RIST Simple Profile is the complexity of the number of ports that you need to open. So potentially it's 4 ports. If you're also using forwarder correction, you need to open 4 ports on the receive side. RIST Main Profile multiplexes all the ports in a single UDP session.
Okay, so multiplexing and encryption.
In addition, it allows you to multiplex multiple streams, not only one stream that uses multiple ports, but now you can mix and match many streams through a single connection, and it allows them to be bidirectional as well. You can have them in both directions.
Okay. What about embed control? Can we do that?
So Simple Profile cannot embed control. It's pure RTP carrying transport string. It can carry anything over RTP, but it's unidirectional RTP. With RIST Main Profile, it includes a tunnel that can carry any type of IP traffic. So you can carry on top of it not only control, but things like DNS queries, SNMP. So it's almost like a VPN. It's a tunnel that can carry any type of IP traffic.
Yeah, you said the word that I was setting you guys up for, VPN. So we got a tunnel, we got encryption, and we pass anything in there. So why didn't we use a VPN then and just use a VPN package?
So that was one of the options, but since RIST is a standard, it specs. VPN, there are several VPN implementations, so we chose a spec of a tunnel that you can implement a VPN with. We chose to use GRE. Some VPN implementations use GRE, some are commercial packages. We ended up choosing something that was both simple and can be specced and not tied to a specific VPN implementation.
I would call it a minimalistic VPN-like tunnel that anybody can write and integrate into their applications.
Okay.
And also, from a lot of vendors have FPGA-based implementations. It's hard to cram OpenVPN into FPGAs.
So OpenVPN was one of the options, but it was difficult to implement. Okay. So encryption. One of the features in RIST is fixed key encryption, right? There's some people who think that fixed key encryption is insecure. Anybody wants to talk about that?
I'll tackle it. Well, to them, I would say, do you think when you connect to Wi-Fi with encryption, the connection is insecure? Everybody's trusting it, and there is a fixed key on each side. Fixed key is insecure when not implemented correctly. When it's implemented according to all the specs, it's as secure as it can be as any other connection. The insecure part, and this is where the misconception comes, is that the key has to be shared among both sides. So it's insecure in the sense that somebody can intercept the communication when I tell you the key from the other side if I don't do it in a secure way.
Okay. What about looking at the traffic and trying to reverse engineer the key? Is that possible?
Some people say there is, but I haven't seen any real evidence that you can crack an AES 128-bit or 256 stream with brute force. It would take, according to the pure theory calculation, several hundred years
Okay.
with today's computing power.
My reservation about using a fixed key encryption is not necessarily about using this fixed key encryption, but about using a non-standard encryption framework is not the fact that the key can be deciphered from reverse engineering the AES, but from side channel attacks. And this is what I think is appealing about using DTLS within the RIST Main Profile. It is a proven stack based on TLS that 90% of all internet traffic are using it, and it's well studied. And there are at least no known side channel attacks, and if there are, they will be fixed immediately.
Okay. So RIST uses the TLS for negotiation, but there is also fixed key. So what you're saying is the TLS is good because it's out there, it's vetted, everybody knows what it is. And the fixed key we used in RIST is not quite there? Is that what you're saying?
The ciphers are sound. Ciphers are very strong. AES encryption, symmetric encryption, it has no known brute force attacks except for maybe with quantum computing that can practically get the key out of an encrypted session. But there are a lot of details when implementing encryption, and need to be very careful about initialization vector and all sorts of details that this is usually how encryption schemes get hacked into.
Okay. If you reviewed what we did for initialization vectors and everything in RIST, so you think that's good enough?
I think that I don't know how to hack it,
Okay.
but it wasn't studied.
Anybody else wants to take that one?
Well, we followed all the NIST standards and documentation and white papers that guide you on how to make the proper implementation of fixed keys so that it's not hackable. So maybe it's hackable, we don't know how.
Yeah.
Okay, so you guys think we're taking a chance there?
I think it's a good method, but it's people that want 100% guarantee that the security scheme is unhackable will probably be reserved about using something that's not vetted.
Go ahead.
I would make the comment that this is why RIST should have been developed in an open forum, but yeah. Encryption famously has lots of academics working on it, but when you do this in a closed organization, this is how encryption gets broken, because it cannot be peer reviewed until it's already published. And at the moment, the peer pool is very small. I think single digits.
Yes.
This is not really, yeah. But then again, we're in a room that's based around standards being developed in a closed shop. So there we go.
But I mean, it's you're not going to use maybe a fixed key for everything. It's for certain use. You have DTLS for a lot of use cases, and then you have this for multicasting or for implementations without real-time clock. Or
Right. I mean, it was necessary to have a fixed key implementation regardless, because we had use cases that couldn't be covered by the DTLS approach. So in order for us to have the maximum reach of this protocol, we needed a fixed key solution. We think we got the most secure one there is. We think that we implemented it correctly. I personally think it is. And the only thing it doesn't have is authentication that DTLS provides.
Okay. Let's talk about authentication. Do we actually need that?
It's a good question. I would argue that yes, because you want to not only be able to encrypt the content, you want to be sure that the person that you're talking to on the other side, it is indeed who it claims it is. Because it might not be, the encryption might not be decipherable right now, but if you send it to a hostile party, they might analyze it offline, and in a few years' time, they might be able to see what the content is. So you don't want to establish a session with a man in the middle that's not who he claims he is.
Okay. Kieran, yesterday you said that you had no use for any of that. Can you comment on that?
I've changed my mind slightly in the past hour. Someone gave me one use case.
Okay.
That's quite niche. So for in all of our customer sites, the biggest problem we have is security. These devices are in remote places. They need to be controlled centrally with some form of encryption. So the vast majority of sites have a VPN already to do traffic, to do SSH, to do HTTP, to do control, from a variety of vendors, some of which are commercial IT vendors, some of which are open source solutions. It doesn't really matter from our point of view. It's a tunnel that traffic goes over, and this is how dozens and dozens of sites are controlled. And so we just put the video over that same network. There's a big caveat. You need to choose a VPN that's capable of handling UDP traffic. Some of them say they do, and they fall over because they don't have the forwarding plane for this. They're doing some kind of TCP forwarding. That said, the use case that came to me was broadcaster exchange of content. So in that case, you wouldn't be able to necessarily co-locate a VPN on someone else's network. That may not be possible. So if that was the case, then yes, there would be a use case for this encryption and authentication side of things for exchange purposes where both sides handle the security aspect themselves.
Okay. You in particular, Kieran, you have implemented RIST, but you're not part of the AG.
Yeah.
Is that a limitation, or you're kind of behind, right? Only once we publish that you can.
Yeah, but I mean, as I mentioned yesterday, the protocol we implemented that was a proprietary ARQ was, I think it was like a 20 or 30 line change to actually be RIST compliant. Because our solution is software, it was updated in the field within about 10 minutes.
Okay.
It wasn't really a big issue. It was very, very close. What you published was essentially RFC 4585, which is when you make a WhatsApp call, you make a FaceTime call. This is what it's been using for 20 years. It's a solid standard. This is why 20 years ago we're still using this standard. Billions of people send messages and make calls with this every single day. So that's really why we didn't choose something like SRT, which is completely homegrown, a homegrown sort of hydra of different things that they've decided. So in that respect, yes, but as our company, we have a policy not to play this sort of standardization thing where if you're part of the group, you get to implement it early. We implement it from what's there and test it afterwards. That means they're interoperable, etc. I mean, you've got 20 demos for the last 5 years that have nominally been interoperable by people who say that, but go to any field deployment and people will tell you otherwise. There's a reason for that.
Okay. I want to explore one comment that you made.
Yep.
So RIST is being developed in the context of the Video Services Forum, and it's true that in order to participate in the AG, you need to be a VSF member.
We are VSF members, I believe.
So,
I was not involved, but we have not signed the participation agreement.
okay. So, do you think that this should be more open, or should be done in another context? Or?
Yes, IETF, or just as a set of recommendations on top of IETF standards. Just, this is how you do it for video. Yes, we have some unique requirements with transport streams that the video conferencing guys like FaceTime, WhatsApp don't really care about. So null packet removal, for example, yeah, that's video specific. There are a few other things which are professional specific. But these, in my opinion, if I was in charge, and I'm not in charge, these should just be a set of guidelines to do things. 2110 is a classic example of how it's gone wrong. There are 3 different ways to represent the first line of a picture. There's the RFC way, there's the VSF way, and there's the SMPTE way. That's a classic example of how not to do it. We literally have code now with heuristics to detect which implementation the end user is using and fix it. I mean, it's a classic design by overcommittee problem. As a part of IETF, that means you could have a much wider range of groups support that. That has its problems because you have more committee effect and you will get random people who don't know what they're talking about. But the benefit is there's a reason you're using these standards is because they were good and they were developed by people who knew what they were doing. There's a reason we're using them today in much more complex workflows than they were ever intended for.
Okay. Thank you. Anybody want?
I tend to agree 100%, either by IETF or if it's specific for video by MPEG or groups with larger participation and reach.
So take it out of the VSF.
I
would say maybe SMPTE, but that's
even worse.
Completely
that's even worse. Out of the fire into the frying pan, right? So that then we'll have a timing model for RIST on like you have to send a retransmission between 2 microseconds, maybe making an addendum to 2110-21. You'd get it even worse. It'd be RIST over SDI maybe.
Well, one of the It's a small committee, but we get things done, I guess. Maybe I'm biased because I'm part of it.
I'm not. This is not a comment on the engineering capabilities of people. It's a comment on the process.
Well, I think there's a big difference here, is that this is not a standard that came from the need to make this work. We were all making it work before. This was sort of all the companies joining together that have proprietary implementations and making something that we can all use. I don't think that you can have that company synergy anywhere else but in a more smaller group among those companies.
Okay, anybody else?
I mean, you've made the comment with encryption. I think that's you're reaching areas where you do need more eyes, whether you like it or not. Encryption is the area where you really need to know what you're doing. You really need to have people who've done this for 20, 30 years who can say something that's trivial to all of us can be like, no, you can't use this if statement here because there's a reason if this if statement and whatever. And I'm not going to say that, but it may be the case as soon as you publish, some cryptographer goes, oh no, but there's
exactly.
this. It may well be the case. And this happens with other standards in other groups.
But this
Wi-Fi is a classic one. Like
Well,
WPS. How many years did we have WPS? That on Wi-Fi that was really, really basic encryption and was cracked immediately, and then we had to already move to a new one straight away because the keys were too simple.
Yeah, but this is really the area that in the specification that's new by us. I mean, that's not building on existing standards.
Yeah, what we're talking about here is the fixed key encryption.
Mm-hmm.
That's the only part that we invented, actually.
We mitigated the risk by having the solution analyzed by companies that do this for a living. The companies that do Wolf SSL, for example, they analyzed this method. They actually were, I would say, 50% responsible for what we got.
Okay, so it went out.
I consulted with them about what is the best and most secure way to do a PSK in our environment, within our boundaries, within our headers. And they said, if you want it secure, you need A, B, C, and D. And that's what ended up in our spec.
Okay, thank you.
That's good to know. I wasn't aware of that.
Yeah.
I wasn't part of the process.
Oh, yeah.
So I didn't know. I genuinely did not know that.
Yeah.
All right. So let's move on with RIST Main Profile is something that is not published yet. We have a demo running to YouTube, but we're still finishing up. And we just had our first round of interops. So anybody wants to talk about their experiences on bringing up RIST Main Profile?
Yeah.
Mikael, probably you, who was the very first one. Many arrows in your back?
Yeah. Well, I was doing with the West Coast US, so lots of evening work. Yeah. No, but it worked great. The tunnel came right up. The encryption DTLS came right up. The big problem we had was with internal IP address settings, and I think we had our opinion of how it should be, and Kieran had theirs. And we were pretty sure that, the document is fine and it's perfect. And then, we realized it wasn't.
It wasn't fine.
No. So there was, went back to the group, and it was 3 weeks of more discussions. But I think what we came up with was something that was actually quite elegant and really allowed for, set a baseline for interoperability, and then allowed each vendor to actually invent and do good stuff. So.
Yeah, it was a very spirited discussion. Anybody else want to talk about that part of the discussion? You all happy with what came up?
No complaints.
No complaints?
No,
Well,
it's flexible enough. It's
flexible. Okay. So the other thing that we are talking about in RIST Main Profile is some extensions for high bit rate. Extended the sequence numbers, high bit rate, and high bit rate sometimes means, or may mean, uncompressed video. So anyone wants to comment about the applicability of RIST to uncompressed video workflows?
I would say it's more useful than FEC. There was a profile, I think, for FEC over uncompressed, but implementing these huge matrices, I mean, very complex. So in that respect, retransmission is useful. So for those who aren't aware, FEC requires building a matrix of packets and then iterating through the matrix once a certain number of FEC packets have been received to correct errors. But I think it's 2022-6, which one part of it had some very, very large matrices. I think that was the reason many vendors didn't choose to use it. In that respect, doing uncompressed and purely uncompressed video is useful. But there are other issues which we may come up to.
Yeah, it's one thing that might not be as useful to using uncompressed error correction is the errors are very local. Sometimes you just lose a pixel. So do you really care? Do you need to retransmit? Do you want to delay the stream if the errors are that sporadic?
Duplicate the co-located pixel or the co-located set of pixels, and the chances are it's going to be so irrelevant. It's going to be statistically very unlikely for that to even be noticed.
So if you're using RIST for uncompressed, it almost means that RIST is for the internet. You see that merging with uncompressed video?
Yes, with AWS Direct Connect, 400 gigabits, which is, yeah, sure. They're going to be those guys are going to be the guys first to implement 400G in their network. There are practical considerations as to whether it'd be a good idea to run uncompressed over these kind of in an internet-style application, but remember, we're using technology from 20 years ago when everyone had dial-up. Well, nearly. Like, of that transition, I'm not sure if the creators of RTP thought we would still be using it in the way we are today, by so many users in such a wide variety of industries.
Oh, 16-bit sequence number.
You hit the nail on the head with the problem, but for that transport stream packets as well, MPEG transport streams, or the max PES size of whatever, and there's all sorts of things like that. Oh, RTP, the number of codec formats, the dynamic payload ID. I don't think they really thought that. In fact, and that's a testament to the quality of their work, actually.
Okay. So maybe not. All right. So since I started talking about this, let's talk about other uses for RIST. Obviously, RIST is used for video transmission over the internet, contribution, that kind of stuff. Do you see it being used anywhere else? Any other applications, any cool applications for RIST?
Video conferencing, where the SIP stack and associated, where you have streams which are in separated flows, can be quite complicated to implement. In our company, we will, I think, we considered it, had this discussion, we'll just use it for internal company communications. It's so much easier. We'll test our own product. Like, what's the phrase? Dog food your own product, right? So yeah, we'll use that. That has other applications. You talked about tunneling traffic over networks, so I guess companies which have appliance-based products where the user can't install particular software, that probably will allow the ability to allow much more control, to allow encrypted access to the device over the internet. That's really useful. That's a problem we see. That's a problem this industry has, is there's thousands of devices just sitting there on the public internet. There's a huge security risk. RIST will be really useful as a mechanism to secure those.
Okay. Anybody else?
Another possible is esports, in the generation of content on PCs, on gamers, that type of thing.
So you're thinking a gamer sitting at home and streaming his own thing.
A game playing a game with a camera pointed at him and other people wanting to watch that. I don't know why they would, but there's it's very popular nowadays among young kids.
So I would say that anywhere that RTMP is being used today, RIST has a good potential to replace it. When viewing video in a browser to the millions and so on, this is not where RIST is going, not where RIST can help. It's not compatible with CDNs, caching, and so on. There are no implementations.
Getting it to the CDN.
Getting into the CDN, yes, just into CDNs is.
Or into an infrastructure, into the cloud, et cetera.
So you think RIST is what's going to finally kill RTMP?
Unfortunately not.
No?
RTMP is here to stay because of legacy.
But the tunneling, being able to tunnel remote production stuff is really powerful if you want to just send something out to somewhere and the recipient doesn't even know what it is. Just plug it in and then the technicians can sit at home and set everything up. And
Right. The key is when somebody already trusts you to bring a video stream over the internet, they're opening the firewalls, they're opening the ports, they want that stream or they want the stream sent out. they already put a trust in your product, in this device. So going from there to managing other traffic is just a small leap of faith as opposed to asking for a VPN.
Okay, yeah. We had a big discussion about routing and not routing. So you don't see that as a security risk, right? Having in-band traffic.
I don't. I think it's going to be a matter of trust. I think that a company will choose a manufacturer, a brand, and it will trust that that device will not let traffic in and out except for what it's configured to do.
Again, personally, I'd use a VPN that has a wider industry usage. Well, it depends. Some VPNs are popular. Commercial VPNs have been attacked in quite interesting ways. Let's not mention the name, but it's been in the media. It's quite interesting. They've had engineering test username and passwords just work because they forgot to remove them. But personally, I would not do this. I would let RIST stay to video. That's my personal opinion. But I know other people have different opinions and good reasons why they want to do that.
Anybody want to comment on that? Okay, so RIST is best thing since sliced bread. Now thinking about simple profile, main profile, what's missing? What's next? What do we need to work on?
Have you talked about null packet removal? Is that in main? You've not covered that one yet.
Yeah, no packet removal. I think that's a corner case, but we can talk about it. But that's in main profile.
Yeah, but it's useful for us, I would say, because for most of the time, 23 hours of the day, sometimes these circuits are just color bars. It would be useful not to waste that bandwidth. Equally, it would allow free space for retransmissions, the bandwidth. And in some cases, that might be useful. It's not very often in a VBR stream, for example, that all of the bit rates being used. So that would actually be quite useful for us.
There is one property, we didn't talk about it, but there's something you can do even without null packet removal in order to save the bandwidth in a RIST main profile, and that's to use the compression property of DTLS. You can turn on compression, and then it will do like a zip compression of every packet. Nulls will get eliminated, not only null packets, but also empty nulls in the elementary stream might be reduced.
Which is, we shouldn't be using those to begin with
That's
anyway.
true.
Right. That's one thing we didn't add to the main profile that perhaps we should also talk about for the next, use some form of compression, a standardized compression on the stream.
Yeah, that's good. This is something that just came up. Well, maybe you know, but I didn't. So is it possible to do right now? Do we need to change the specification?
The specification don't mandate how it mandates certain ciphers, but it does not mandate how we implement DTLS. And compression is a property of DTLS. It has its downsides. Some say that because packet sizes, there might be some side information leak in there, and it might reduce the efficiency of the encryption. Not the efficiency, but the strength of the encryption. But it is a property and it's built into the standard and built into the library that implements the standard.
Okay, so it's something we can use today.
Yes.
See, I'm sharing this and I just learned something. Thank you. Okay, so no package optimization is something that's in RIST main profile, which is you don't have to transmit the null packets, right? And you keep the timing. Are there any downsides you see on this, or is it free?
I don't know, some people generate their clocks from packet arrival times, so if you're deleting the null packets, you have problems.
It can create problems. For example, let's say there is congestion. So you save the bandwidth, but you don't know there's congestion until someone turns on the light, and then the video breaks.
Yeah.
Okay. So that leads then to the question that I asked, which is, what's next? What's missing? What do we need to work on next?
Well, adaptability is the word that comes to mind based on one of the talks that was given. What happens when we have a stream that is this big and suddenly the pipe shrinks to this size for an amount of time? Right now, we just collapse. That's it. There's no way to put the data in. So,
no, but you could listen to the rate of retransmits on your encode. It's vendor independent.
Yeah.
It's for the encoder vendor to decide if they want to react or not to the number of retransmission requests. So it is possible, but that's an open question. Do we standardize this?
Right. Do we standardize managing the bit rate of the incoming stream somehow based on feedback from our protocol, or do we leave that outside of the spec?
Yeah, I would argue that it is, like Kieran said, that it is possible today with Simple Profile. It's up to the sender to decide what it sends based on the feedback that it gets. There are certain feedback on the RTCP packet that some vendors don't fill up. That allows you to measure round trip time and so on. So we might need to standardize those. What fields are mandatory?
Yes, Simple Profile opened up for sending empty receive reports for, and a lot of vendors do that. So
I mean, we defined this traffic of RTCP and hello messages, but we didn't specify what to do with it. You know, what useful data can we put there that will help an implementer?
It's interesting. So you guys saying that it may be possible to do it with Simple Profile without changing the spec?
I would say yes. I would say that RIST defines how packets look like for cross-operability, but it doesn't tell you how to do things. Much like MPEG standards that tell you how the bit stream looks like in order to have compatibility, but then doesn't tell you how to encode.
It's more you could use heuristics to go and figure these things out, and I think you could do maybe a reasonable job. I think there's additional data that might be useful, but you could do a reasonable job, I think, as it is.
Right, the spec define how to communicate with each other and you know, the protocol itself, but it didn't specify. It left room for everybody to implement their own buffering mechanisms, their own retry mechanisms, congestion control, jitter control. That was all left to each implementer to use their magic sauce.
So is there, I'm going to ask this again. All right, so it may be, we all agree that adaptivity in the encoder, namely, if you have a 5 megabit per second stream and your pipe shrunk to 3, no ARQ or error correction is going to make it fit. Right. So you got to throttle down. So in order to have a good, viable solution, you have to do that. Now, the question is how much of it we standardize, because the purpose of RIST is to be vendor compatible. If it's a Cobalt encoder with a DVEO decoder, it should work. Right. So, and it doesn't right now. So what else do we need to do?
Well, I think the key is we need to decouple the encoder from the protocol, because not everything is going to be an encoder. You know, some people are going to have devices that transmit some other data or data that comes from vendor A, B, and C. So having the standard of the communication between our RIST protocol and the encoder would be very helpful in the next profile. How do we communicate to the encoder? Hey, I'm down to 3 megabits. Don't send me more than that.
Okay, so one thing we need is a standard protocol to control an encoder.
Correct. Some sort of API, standard way of talking to an encoder.
All right.
You really want this?
It's in the advanced profile. That's
yeah, but there's already SCTE have published something for this, and no one uses it. Like, when I first started this company, I thought, yeah, we need to have people have some standardized way because I believed all the standards Kool-Aid, and actually people just want something that works. What do you want in particular from that? Again, you're right. Things are not what you seem. We can have streams, for example. There's lots of manufacturers that streams have the correct parts per million offset because they reflect their clocks, and then something that's played out in AWS, for example, hits them and it just goes to black because they assume everything is an encoder, but it's not anymore. Sources are generated in all sorts of places nowadays. But what would you want to see from an encoder?
Well, maybe the API needs to be on our side, a way of any device to query our system to see how much bandwidth we think we have.
Yeah. That's useful, yeah.
You know, that way it can be used by anybody for any purpose.
Well, that's a good question. How much bandwidth do we have? Mm-hmm. Do you think that we should standardize a method to figure that out, or just leave it open?
I think leave it open. If you standardize them, look at TCP. TCP is a classic example of why you shouldn't standardize a method. We've been stuck with this. This is a case where people didn't think about the TCP was designed for like networks where what's the exact? There's a figure of speech for it, but packet loss is proportional to the congestion, and that's not true on cellular because, for example, where I walk behind you, momentarily I will lose the bandwidth, but my overall throughput only momentarily dropped. And if we're stuck with a standardized bandwidth measurement, we'll be stuck with this for 30 years, and everyone has to deal with it.
Right. I think the method of measuring is not as important as the ability for external devices to query it and get a number from us.
Yeah, sure, as long as it's upgradable in the future.
Yeah.
Sure.
Part of RIST is also to be able to collaborate on standards that compete on implementations. So you could, I mean, you're getting into that part where the secret sauce happens, right? Where you can differentiate your solution. You can have a better way to do this. Of course, we could suggest one like basic level that everybody at least does to get some, but yeah.
Okay, so some of you guys are encoder, decoder vendors. So let's think this through, right? Let's say a net inside encoder talking to a DVEO decoder. What do you want to see? You want him to open an API?
I think there's two levels here: the communication between the encoder and the RIST, layer. There needs to be one level of being able to query there, and the other one between encoder and decoder. When then we end up, maybe with different numbers between vendors.
The encoder's sitting there just pumping data. It doesn't know anything. It doesn't know any better. It has to be told.
Doesn't even know what's I don't even know what's downstream in some cases.
Yeah,
but
The only way I can find out is from the decoder. Sorry.
the encoder knows how many packets it's retransmitting, so he knows how bad the link is.
Yes.
He also knows if he's keeping track of the retries, he's going to know.
So I mean, there's some things that I would find useful that are more detailed. They already exist in IETF land. So with regards to if I've lost a packet, figure out which reference frame it was. That means that I already have this capability internally. I could choose not to encode from that reference frame immediately. That's quite useful. There's a few other things. It would be quite interesting. I think this is already doable. We've discussed this, to be able to time synchronize streams. So I'd have two separate encoders and have some ability to try and figure out how to have decoders automatically fail over between the two based off relative loss characteristics. Be interesting if there was something vendor interoperable, but this needs to up for discussion.
This looks more like your secret sauce.
I don't have any secret source. It's all on GitHub. I don't do secret source.
or something that you leave to the encoder. Do you see a need to standardize something like that? Yeah, there's.
I have use cases where I want two of yours to talk to two of mine, and I want to fail over cleanly for the end user between one, if a particular line or there's one of them has a power cut or something. This is a problem.
I think we need to also maybe in advanced profile try to standardize some kind of terminology, because now we're talking encoders and decoders, we're also talking RIST senders and receivers. And
That's a good point. Being a encoder decoder vendor, I always think in terms of encoder decoders, and people like Uri, who makes gateways, is thinking differently, right? It's a sender and a receiver, and can I control this? And maybe it's not an encoder, it's a file.
So here we have a similar problem because we support 2110 and 2022-6, so we are receivers, and an encoder is a receiver and sender at the same time, and a decoder is a receiver and sender at the same time, so the terminology makes no sense anymore.
Yeah. And like if say you're cooperating with third-party encoders, then even if we decide on an interface that we want to tell them, if they're big enough, we're going to have to implement their way of doing it. That's just, you're going to have to do several different ones.
I would say, or I would suggest that RIST needs to be unopinionated. It needs to expose data that it knows of, for example, packet loss and so on, and let vendors decide what to do with this data.
So, yeah, the sender has some idea of the quality of the network from the retransmissions. The receiver definitely knows what's going on.
The receiver has more data, but we can do something where it exports the raw data and makes no conclusions.
It would be useful, for example, to say, have some mechanism to have data priority based off dropping, so that, imagine you're doing an interview with you. If there is packet loss, it would be useful for some mechanism to say, hey, this is reaching the stage where I don't have my video, and I know as a decoder how much video is basically useless now, but I still want to be able to talk to you, and then bandwidth is still there for audio, and it's still possible to continue the interview. Ignore there's practicalities, like if clock recovery through SDI, there's issues, but imagine there was enough bandwidth to do that. That's a thing people would want in the real world. We could continue the interview, and you would just turn into a pixelated mess, but we could still continue the interview.
I think that goes back to the adaptability that we're talking about. Maybe we should add the ability to prioritize packets, so that if we run out of bandwidth, we start with the high priority ones and drop the other ones.
Because in MPEG-TS, the priority field is 1 bit. That's kind of useless at the moment.
I think we have spare bits that we can use.
You see, it's the RIST group in action now. That's why I introduced this subject, because it's the next thing that we're going to talk about. So, adaptability. Now, some of you may have been to the talk yesterday. It's very easy to know that you are in trouble and bring it down, but how do you bring it up?
It's a whole lot. There's
Yeah,
there's
there are
whole
so many, yeah.
academic subjects around this, you know. How long is a piece of string? I mean, seriously. The whole conference is dedicated to this entire topic. I mean, yeah.
Yeah,
There are many techniques. It's
yeah, it's not my intention to have you guys discuss the techniques. Yeah, there's many ways of doing that. But the question I want to throw in is that something we should standardize?
No, definitely not. History shows this is a bad idea. We could all be using 5G, or no, XG. We don't even know what the interfaces of the future will look like, and we'll be stuck with 188-byte TS packets. We're stuck with this from when? Like, I don't think I was even born when this decision was made. Like, yeah. The thing that people don't realize, the narrow profile, there are decisions now that will be made and affect people when you guys are long gone. Like, that's the problem.
Yes, but on the other hand, we are designing something within boundaries. This is not something that is going to work for microsecond level delays to 5 minutes level delays. Our space is limited, you know, milliseconds to hundreds of milliseconds. That, I would say that's our range of buffering. And within that range of buffering, we can make some suggestions.
Maybe.
Yeah, so what I was asking, Kieran, is should we standardize maybe the method of measuring or a protocol to measure, or not even that?
Some kind of method and some kind of protocol to exchange information, absolutely, that would be nice.
You'd like a method, but the TCP and cellular is a classic example of why the method is not a good idea. They couldn't have envisaged mobile networking when they wrote TCP, and now we're hamstrung by it. I mean, this is the classic reason. There will be methods of exchanging television, Starlink satellites. So when one satellite goes over and there's a hop between the others, that might, if we define a method and then the Starlink satellite flips between the two and it's a temporary drop, we might react badly because the method was designed before the satellites were even launched. Like, we need to have technology that's capable of handling things from the future.
Excellent. Well, thank you. Any other comments on that? Are there any questions from the audience? Yes, just a sec. Let me bring it up.
Hi. Before being in this industry, my background was in video calls. And they've been doing low latency over the internet for 20 years.
I covered it, yeah. You missed it. You came late. I said all of this.
All right, so.
You are correct.
Yes, so for example, adaptivity, there's a problem that's deployed in everyone's browser, right? There's the Google Congestion Control, GCC, that's deployed. There's a third at the IETF around Scream and NADA from Cisco and Ericsson groups. Why not just adopt these, right? That exist, that browsers will deploy.
Kind of covered it a bit. Yeah, you missed it. You weren't here, but we covered all of this. Sorry, but yeah, what was the conclusion for it? This is my personal opinion, but you guys can comment. But I don't think we need the complexities of SIP. We don't need the complexities of separated RTP flows and all the complex negotiation around that. We don't we need something just simple is the wrong word because it means something else. But we need something built around IETF standards, which I've said have been good. You know, these are quite old standards, and they still work because they're good, right? You make FaceTime calls, you make WhatsApp calls, they work. But we don't need some of the complexity that these industries have. We're not delivering to browsers, by the way. We're a B2B system.
Yeah, but they have good technology there.
Yeah, sure.
Things like as simple as TMMBN, TMMBR, right? The receiver telling the sender, this is my maximum bandwidth right now.
There is no reason why we couldn't implement some of those standards. We actually, in our meetings, prefer to start with a standard that exists, if there is such a thing, and it applies within reason to what we're doing. If it's too big or too a wrong fit, then we say, okay, we're going to use this particular standard. But we prefer to implement standards within our recommendations.
Yeah, one of the driving forces of, the guiding principles of RIST is don't reinvent the wheel, but let's let's choose. If there's something that's suitable, let's choose that something that's suitable.
Yes.
That's why it's RTP on the transmission, RFC 8085 essentially for the retransmission, DTLS on the encryption, GRE, RFC 8086. We're just putting the toolkits together and inventing the minimum. So the adaptivity is going to be a hot topic, as you can see. We haven't dealt with. It's the next thing in the agenda. And if you want to participate, just call in.
Absolutely. Yeah.
Any other questions? All right, thank you very much, and thank you, the panelists, for making the time.
Well, and thank you, Ciro. So just to remind everybody, these presentations will be are being videotaped, so you'll be able to see these on the VSF YouTube channel, and there will also be links on the vsf.tv website. So make sure, if you want to relive this experience, or if you missed part of it or whatever, you have a chance to take a look at it. And thank you very much, gentlemen. I really appreciate it. All right, Ciro, appreciate it.